Hello everyone, my name is Jagjeet Singh Bhatti and I am a postgraduate student at LBU studying my master's in advanced engineering management, and today I'm going to share my research on the topic environmental impact and sustainability of fire detection system. It's a review of eco-friendly material and energy efficiency. So I chose this topic because I wanted to understand a big problem. We see these fire alarms every day on the ceiling, that white kind of thing on the ceiling, but we really think about it. They are really life-saving heroes that keeps us safe. But the material inside them, the electricity they use, and the trash they create cause a hidden environmental footprint on our planet. In this presentation, I'm going to walk you around through the exact sequence of my academic poster to explain the problem of the green solutions. So let me just give you an overview of my poster. So the fire alarms are absolutely essential. In England alone, fire services responded to exact 13307 fires between 2023 to 24. This shows how much we rely on them to protect us across residential, commercial, and industrial buildings. However, conventional fire detectors are made of traditional plastic, non-recyclable electronic parts such and use constant electricity. This leads to high carbon emission, the, com- the, con- the consumption of natural resources, and lots of electronic waste. My study explores how we can use a sustainable approach, including plant based materials, energy saving designs, and life cycle assessments, to make these safety devices completely green. So, um, let's come across some of the aims and objective which I have enlisted in it. So, the main goal, or you can say, uh, the main aim of my research is to analyze the environmental consequences of the fire detection system for the beginning of their life cycle to the very end where they are discarded. To this, to do this, I have five main objectives. First, to identify the major environmental hotspots during the manufacturing and usage phase. Second is to evaluate traditional material like fossil fuels, toxic metals, and chemical flame radiants. Uh, Third, I would say to look at green alternatives such as plant-based materials, biodegradable circuit boards. Fourth is to evaluate modern um, energy saving techniques like smart sleep scheduling and energy harvesting. Fifth is to create evidence based suggestion to build a circular fire safety industry. Uh, so, why is this study important right now? So, in my opinion, I would say this uh, while scientists focus on how fast and accurate fire alarms are, their environmental impact is almost always ignored. As we build more smart buildings, we are putting more and more millions of new detectors. This is increasing our global carbon footprint. When we look at the traditional methods, the problems are alarming. Plastics like ABS do not break down in nature. Furthermore, the heavy metals inside the electronics and chemical additives um, called BFRs raises severe concerns about microplastic and landfill toxicity. Top uh, on the top of that, because these alarms are always powered on the standby electricity they use add up over time. My dissertation bridges this gap by bringing sustainability directly into the fire safety engineering. So, so when I received this existing literature, I looked at the damage caused of electronic waste, which we call as e-waste. The e-waste crisis is in 2022. alone, the world produced 72 million tons of e-waste, and scientists predicted that the number will climb up to 82 million tons per year by 2030. Shockingly, only 17.4% of the electronic trash is properly recycled. Plastic and toxicity up to 25% of e-waste by weighing comes from traditional plastic. When these are discarded, they break down into microplastics. Studies shows that fossil around electronic waste dumping sites contains up to 100 uh, 100,000 microplastic particles kilo, per kilogram. The circuit boards, the circuit boards, uh, the printed circuit board, the printed circuit boards make up to 3 to 6% of e-waste by weight, but they are packed with heavy metals. For for instance, about 20% of a standard circuit board is made of copper. When when thrown into ordinary landfill, these heavy metals leak into our surroundings. Scientists have found that soil concentrations of up to 835 milligrams of copper and 469 milligrams of lead per kilogram of soil, which are way above safe environment. If I talk about the methodologies to find all the specific numbers, I used structured approach called qualitative semestic literature review. Instead of doing lab experiments, I acted like a scientific detective by reviewing high quality researches that has already been peer reviewed. I used Google Scholar. That's the best thing I've ever used. I used the Google Scholar database to search for the most up-to-date findings published between the year 2011 to 2026. I started with a massive initial pool of 115 and 100 results. I then applied strict inclusion and exclusion criteria to discard all non-academic and biased reports. This left me the exact 20 high quality studies, which I analyzed based on material innovation, energy efficiency, and total product life cycle. So, um, as a result, I got to know that from the 20 papers I studied, my results revealed, um, it came to know me that some incredible hopeful solution to replace our old polluting systems to is by simply using recycled plastic, like recycle ABS instead of brand new oil based plastic. We can reduce up to we can reduce greenhouse gases and save resources up to 30 to 50%. We can switch our which can we can switch the outer casting of alarms at polylactic acid, or we say PLA, which is a bioplastic made from plants like starch and sugarcane. Using PLA decreases carbon emission by 14% to almost 70% and uses 25 to 60% less energy during the manufacturing. I was surprised to find that 40% to 70% of the entire environmental impact of an electronic device happens while it's just sitting on the ceiling and waiting for the fire. By using smart internet things like IoT technologies and sleep schedule, we can save up to a lot of power. Instead of staying awake at full power all the time, the alarms can take micro naps. It keeps for a split seconds, wakes up just to test the air, and goes right back to sleep. This is clever technique to reduce operation energy by up to like 40%. Using energy harvesting technology like small indoor solar cells or room heat can make the sensor self-powered, allowing batteries to last for more than 10 years without even needing to change it for years. Let's just discuss what all the specific numbers mean to the fire safety industry. To make a real difference, we need to transition transition to a circular design approach. Circular design means we build the fire alarm to last longer and we easily take apart. Instead of throwing away a whole alarm, we want small piece breaks. We should use modular design. This means the outer shell and the battery and the sensors are separate pieces and can be fixed or recycled industries. However, we must balance the sustainable idea of actual life-saving performance. Since fire alarms protect lives and plant-based materials must be extensively tested to ensure it is excellent heat resistance. Using these materials might initially might raise manufacturing cost up to like 30 to 15 to 30%, and but as a government introduce rules like eco design directive, mass production will eventually lower the carbon footprint um, of building safety devices by up to 20 to 30%. So, if I come to a conclusion of my presentation, then the biggest takeaway of my study is that life safety environment sustainability can go hand in hand. We do not have to choose between keeping people safe from fires and keeping our planet safe from pollution. By combining green materials with with smart energy saving softwares, we can cut environmental footprint and use these systems by by up half by up to half. uh, for my future recommendations I would like for my future recommendations I urge the manufacturers to first test these eco-friendly materials under instance real world fire scenarios to prove their safety, and the second, create a standardized green framework so that fire detectors are rated rated to for their sustainability just as much as their safety performance. Third, make a modular design, the standard across the entire building service sector. And that's it. My name is Jagjeet Singh Bhatti, and thank you so much for listening to my presentation. I hope that the next time you look up at a fire alarm on a ceiling, you will see a device that has a power to keep us safe while keeping our planet green.